I'm excited to be with Patrick Kiley today with Sentry Water Technologies. How's it going, Patrick?
Thank you, Paul. Things are going great.
Good. So, really excited to learn about the new Sentry technology, the Sentry probe to put into digester biogas opportunities. Tell me about the genesis of the Sentry probe.
Good. Thank you. Now, let's get started. This is definitely not a new technology. We are going to say that this is a well-established technology that has been developed, tested, and validated in the US market. Um, and we're really happy about that. So, my story did my postdoc research in environmental engineering at Penn State University. And this is almost 17 years ago. And at the time, we were developing these types of surfaces, these bioelectrode surfaces, for understanding how you could monitor the performance of wastewater treatment systems. So it's a 17-year story. That's just how long sometimes it takes to gain traction in the wastewater and the anaerobic digestion industries. But we're now into year 7 of commercial deployments and really looking to scale. So as I said, we've tested and validated the technology in the US primarily, and over the last couple of years, we've been expanding also into Europe.
Wonderful. So, tell me some of the features and benefits of the probe.
Okay, I love it. So I'll start actually with the challenge. So operators of anaerobic digesters, and certainly operators of co-digestion systems, um, they have no idea what the VFA in their digester is. They have no idea what the health of their digester is. And because of this, most anaerobic digesters are actually loaded at about a third, 25% of their loading capacity. So what we want to do and what we do with our sensors is we provide a really simple signal that provides a real-time measurement of the consumable VFA, i.e. the food that's being used by methanogens, the methanogenic community, to produce biogas. We provide a real-time signal that lets operators see in real time what that level is. And then the moment there's any issue, the moment you've received perhaps a really high strength organic load, or the moment you've pushed your digester too far, you get a notification, you get an alert, and then you can modulate your organic loading. So it's really trying to take that black box concept away from digesters and provide just a really simple signal that operators can use to maximize loading, maximize biogas production.
How does the analyzer work? Does it go right into the sludge?
Love it. So when we first looked at, what kind of sensors work well in wastewater, light-based sensors don't work well. This is wastewater. You can't, biofilm grows all over everything. So what we've developed is a bioelectrode sensor platform. So we want biofilm growing on our sensor. And when you know that, when you want biofilm, you want to understand how much VFA the bacterial communities in your digester can consume. The best place to put a sensor then tends to be directly in your digester. So most of our sensors would be installed typically on the recirculation line of a digester, also on the influent line into your digester, and then also occasionally on the effluent line of your digester. But wherever you can just get access to that anaerobic digester environment, that's where we want to get our sensors.
So, what kind of benefits does the sensor bring to an operator?
I love it. Operators, I mean, their number one goal is I do not want to push this too hard. I don't want VFA building up. I don't want to get into a situation where acidogenesis has occurred in my digester and I have these types of crashing environments. So what we do is we provide this real-time signal to operators instead of having to rely on manual sample analysis, where you get one point every day, typically at 9 or 10 o'clock in the morning. You might have to wait 24 hours. You might have to wait a couple of days for that result. We're providing a real-time signal, so it's always on, and it allows the operator on a dashboard, online dashboard, or on their own SCADA to literally see what that VFA concentration is. They can set certain thresholds. They can then more aggressively load their digester, uh, increase that loading by 10%, 20%, up to 50%. And as they're doing it, they can just see the VFA increase in the digester. And assuming, or as long as it doesn't break certain thresholds, then they know they're operating their digester in a reliable and safe manner.
Is there any lag time or it's truly real time?
It's truly real time because the core of the technology, how it works, is we grow bacterial biofilm on, and I have a sensor here actually, on these sensors. So this is it's really simple. It's got two surfaces, anode cathode pair, and then on the anode side of the sensor, that's where the bacterial biofilm grows. And all we want is we just want wastewater from the digester flowing past that surface. The bacteria do what bacteria do. They consume food, they consume that VFA and respire and generate an electrical signal. So in a very real way, you have this in situ, in digester signal that's telling you both the health of your biomass and how much food, how much VFA they have to consume in that location.
What's the competitive landscape out there? As far as I've heard people talk a lot about NIR as another way to accomplish these goals. This isn't NIR that
No.
you're implementing. How does this compare against other approaches?
Okay. So really what we compete against mostly are facilities where they're doing manual sample analysis Monday to Friday, 5 days a week, and spending money on FOSTAC, spending money on VFA, spending money on COD analysis. That is the most common setup for anaerobic digesters. Certainly digesters where they're trying to operate them in the most efficient manner possible. There are other real-time sensors, but they're typically very expensive, very difficult to maintain. So the level of cleaning that's required, the technical skills that are required for maintenance and upkeep are just really challenging. So we're just different. It's just a simple surface. There's no consumables. There's no moving parts. There's no cleaning. We just want to have these surfaces in your digester and just provide you real-time data.
So what we've talked about on the price point, it seems like it's a very competitive offering. So what kind of ROI do some of your clients typically see through their investment in the Sentry Probe?
All of our clients will see an immediate ROI because we offer clients two ways to use our technology. Most clients start as a service. So they can lease our sensors, pay monthly, pay annually, but immediately we'll ask them to reduce their manual sample analysis, typically by 80%. And the cost savings just in reducing that analysis way outweighs the cost of leasing or using our sensor. But the much bigger opportunity lies with those clients that want to work with us to increase biogas production. So as I said at the start, we routinely see most digesters are actually loaded at about 30% capacity. We set low bars of our customers where we say we want to increase your biogas production by 50%. We just go in increments of 10%, and they can use this data to get there. So really that ROI is obvious for people who just want to reduce manual sample analysis, but it is instantaneous, and the cost of our sensor is inconsequential to clients who really want to push their digester and try and generate more biogas.
So to that point, what would you say your ideal client looks like?
I love it. There's three types of clients. The entry-level client for us is just someone who wants to reduce that manual sample analysis. They have this laboratory. They're paying people full-time to just go and take grab samples and then test, as I said, sometimes BOD, COD, VFA, FOSTAC. It's too much, and it's not giving you any real actionable insight. So that's the first thing we can work with clients on. The second one is anyone who's implementing co-digestion. Because if you're implementing co-digestion, you're having to rely on third parties to tell you what the quality of those feedstocks are. But in reality, that feedstock quality can change all the time. And you need to have in situ data in your digester to help you understand, okay, if I've taken a bad load, I need to be flagged about that so I can go back and talk to this third party and tell them, guys, whatever you delivered to us on Tuesday was just twice as concentrated as it normally is. We need to do better. And then the third bucket, which is the most exciting one for us, are clients who have specific KPIs to try and get a little bit more out of their assets. And we see this as such a massive opportunity in the US. We see clients in Europe who are doing this already. But when you have good data, when you have visibility on your digester, there's no excuse. We can do it. And we can actually build digesters that can, increase organic loading, increase your biogas by 50%, by 100%, just by having that real time insight on how your digester is doing.
So less labor, more gas, and probably more tip fee as well if you're pushing more material through the plant.
100%.
Sounds like a no-brainer, Patrick.
Thank you, Paul.
All right. Good to see you. Be well.
Thank you. Talk
Thank you,
soon.
my friend.